Now let me do a couple examples for you to see how we use these new Boolean identities to simplify logical functions. So for the first example, suppose we have a function x ANDed with x naught or y, and we want to minimize this. Well, the first thing I'm going to do is I'm going to distribute this x to everything that's inside of the parentheses here. So this gives me x and x naught, or x and y, and this is just distribute. And now x ANDed with x naught is equal to 0. So this thing here is 0, and then we still have our or xy, and this is since one of our identities tells us that anything ANDed with its inverse is equal to 0. So that means this simplifies to just plain x ANDed with y. For the next example, suppose we have a function f is equal to x or x naught y or x naught. So for these two terms here, I have an x naught, so I'm going to go ahead and factor those out. I still have my x. Now I've got x naught ANDed with y or 1. And here I just factored out an x naught. And then this thing in here is just equivalent to 1 because we have an identity that says that anything ORed with 1 is equal to 1. So if that's a 1, then we have x or x naught ANDed with 1, and this is since y or 1 is equal to 1. And this is equivalent to x or x naught, since anything ANDed with 1 is just equal to whatever that anything was. And then x ORed with x naught, one of these has to be a 1 and one of them has to be a 0. So if we're ORing something where one of them is a 1, then our result is just going to be 1. And this is from the identity that tells us that x or x naught is equal to 1. So this entire function just minimizes to 1. So that means it's always true. The next example, suppose we have a function f is x or y ANDed with x or y naught. So what I'm going to do here is I'm going to actually FOIL this. So the first terms are x and x, the outside, x times y naught, the inside, y or x, and then the last, y naught. And here I just FOILed. And now x ANDed with itself, we have an identity that says that this is just equal to 1x. And if we AND at y with its inverse, this is always going to be 0. Okay, so that means this thing I can replace with just 1x. I still have my xy naught or yx, and this is just 0. So here I'll say, since x times x is equal to x, and y ANDed with y naught is equal to 0. Okay, great. So at this point, in each of these terms I have an x. So let me go ahead and factor that out. If I factor out an x, I get 1 or y naught or y. Now here I just factored out x. This thing inside of here has a 1 in it. So if I'm ORing a 1 with anything, then my result is always going to be 1. So this is just x ANDed with 1, since 1 or whatever is just equal to 1, where a is whatever, could be anything, doesn't matter. If we OR anything with 1, we get a result of 1. And then finally we have x ANDed with 1 is just going to be x, since x ANDed with 1 is equal to x. So since you see these examples, let me know if you have a question and let's give it a try.